To chapter 12. If you made it this far, kudos to you. You may want to save these in case you ever get really have a rough night and you just can't fall asleep. Hopefully, this will help you get to sleep faster. So, the key concepts of this chapter are going to be talking about the fundamental functions of virtual private networks, the technologies, and the basic elements of the VPN implementation and management. We're also going to follow the implementation of a VPN solution. And the key concepts are, you're going to be planning and selecting an appropriate VPN solution for an organization. You're going to talk about the remote access alternatives to VPN and the VPN solutions, and also about deploying and testing a VPN. Now, as a refresher, there's two types of VPN solutions. The operating systems that are, where you install the software, the VPN solution, on a server that's either running Windows, Linux, or Unix. And like Windows has one called built-in called routing or remote access. They have that natural built-in components for that. And then you have your VPN appliances like they're made by like Cisco, Palo Alto, Checkpoint. These are some major players for VPN solutions. Juniper is also another really big player in that. And these are hardware-based systems. They're rack-mounted. They kind of look like a router or a server, or kind of like a rack-mounted server. They allow remote users to connect in through the public IP address on one interface, and then they have an internal interface which allows them to connect into the internal network. So these are all something that both systems have in common as internal and external interfaces. All right, so let's talk about some VPN appliances. If you're going to be configuring a VPN appliances, most of the modern appliances are designed for like rack and stack, plug them in, plug in your network cables, and then you just go ahead and start to configure them through a web page or wizard. Now, the one thing you want to do is when you plug them in, you're going to have to figure out where you're going to put it in at. This is going to be either parallel to a firewall, which is going to have a direct exposure to the internet, behind the firewall, which you'll have to configure the firewall to allow that traffic to be published into it. Like you could put it in a DMZ or on your internal network. And that's going to be something depending on what your topology is looking like. Or you can put them in front of the firewall where they're totally exposed, and then you create firewall rules for access for that. So anyway, one of the things you want to do is also you want to change the default settings, including the default passwords on those systems as soon as you plug them in. You're going to run the wizard that's going to set up your users, your network configuration, and all that. And that's going to usually be on your internal site. It's going to have some port like 80, 81 or something like that for those. And you want to do is you want to provide each VPN user an individual access account. So you don't want to have a singular account that gets shared among all users. Every user needs to have their own unique account. And with this, you can tie it into your IAM solution, Identity and Access Management solution, which could be something like your Active Directory solution or your whatever solution you're implementing in your network environment, whether it be like something like NIST if it's Unix based, or you're using a third-party identity and access service system like Ping Identity or something like that. The client-side configuration is usually a piece of software that gets installed on the clients that allows them to interface with the VPN solution. Most have clients that are for the Microsoft Windows systems or the Mac VPN clients. A lot of Linux and Unix systems have a built-in VPN software for those. Now let's talk about remote desktop protocol. This is developed by Microsoft that was used in something called the terminal services. Remote Desktop Protocol was the project was called Hydra. I worked on it when I was at Microsoft, and it allowed a Windows server, and each individual user was able to have its own unique desktop interface running on that server. So therefore, all the data was kept on the server, and they would just connect in their protocol wherever they were, and it would seem like, oh yeah, I can connect into my server and I can run all my applications that were applied to me by my system administrators and all that. So it was there. Basically, this was a Windows version of something that was in the Unix world called X Windows, and that allowed for remote clients on that. Basically, it's an extension of the ITU-T T128 application sharing protocol, and nowadays it's called Remote Desktop Connection. Uh, it's an application that uses built-in RDP, and when enabled, the client can connect, log on, perform any actions as if you were on that computer locally, as you do like on your laptops or your desktops right now. Uh, you're actually with RDP, you seem like you're actually on that server itself. RDP is used extensively in situations where there needs to be a jump client and access to certain management functions are, severely limited and restricted. So the client can run on multiple OSs, can run on Macs, can run on Linux, Unix, or anything that can support the terminal services protocol being used. So you're going to see that a lot with a lot of jump servers, and it's going to go from there. So enabling the remote desktop client on Windows. You go into the settings and you find that remote desktop, and you can turn it on for your own local system if you want. Once you enable it from another system, you could terminal server into your laptop from another laptop. Or if you have a desktop, you can do that. Or if you have a server, you can enable remote desktop on a server if you have your home server. If you're using cloud computing, a lot of times this is utilized for systems where you want to have a bastion host set up in your, uh, you know, if you're in an Azure AWS environment, you could set up a remote desktop server out there where you can connect in and manage the internals of your AWS environment, uh, out there too. So that's something that's really useful for that. So if you're using these remote control tools, there's other ones out there, that are built into, remote assistance. Some of it's built into Windows. Others allow, desktop help desk professionals and stuff remotely connect to your computer and see what you're seeing, and if you're getting an error, they want to see it. Uh, some of the third-party tools are TeamViewer, LogMeIn, and Remote PC. WinVNC is one of my favorites because it's out there. It's kind of a freebie tool. I like to use that because I can connect into a number of different things. Um, and a lot of these tools are used by scammers out there on the internet. So if you ever get these calls, oh, yes, I am calling from Microsoft support. You're spewing viruses out there, and we are here to fix it. We're going to charge you some gift cards, yada yada. You log in, and they usually get you to do these TeamViewer or LogMeIn or something like that to use that. So always be careful if somebody ever calls you up and says they're from some support agency and they want to remote into your computer. If you did not initiate it and you do not know who they are, and you can't validate them, don't allow them to do that. So if you're going to be using remote access, remember remote users can be a lot of things that are needed for your business continuity, your business to function. There's a lot of people out there in the field and all that. A lot of these are salespeople, field technicians, your consultants that work on customer sites, uh, anyone who needs to work home, like during the pandemic. This was really used very extensively by a number of companies that allowed certain users to work remotely from home, so it reduced the amount of interactions in person that they needed to do. A lot of times the VPNs are used to create the VPN tunnel that are creating those secure connections, and the tunneling protocols are also used to protect data while being transferred across untrusted networks like the internet. Because remember, the internet is where a bunch of bad things happen. So you want to make sure that your data is not being openly exposed on the internet if it's not encrypted. All right. Some of the technologies for remote use. One of the earliest ones I ever dealt with was point-to-point tunneling protocol. This is a protocol we touched on a couple of chapters ago, and it is PPTP. It was developed by Microsoft. It offers encapsulation but no encryption. Later we have Layer 2 tunneling protocol. This was developed by Cisco and Microsoft and introduced in Windows 2000 and 2003, became more prevalent. Uh, this had the ability to do some encryption of some of the data. You know, the data could be encrypted, but a lot of the other parts of it were not encrypted. Um, After that came out SSL and TLS based tunneling protocols. These are stuff you're going to see more and more often. These are like your extranets out there. For those of you who are going to school and you log into Cougar Web to see all your different applications out there, that is an example of a TLS based tunneling protocol where you can run applications that are happening across that uh, system. You can do a lot of really cool stuff. You can do remote terminal sessions through there. You can publish applications. You can publish uh, other websites, but it's basically out there for that. And then you have ITSY version 2, and this is basically what a lot of us call our IPsec solutions out there. Okay, so let's talk about remote desktop services. I touched on it earlier. We called it Microsoft Terminal Server, codename Hydra. It works in two modes: the remote desktop session host mode, and this is where the server typically provides pools of desktop sessions and applications for everyday workloads. A lot of times companies will call this as virtual desktops out there, where you can do a remote virtual desktop or anything like that, and all that. Um, and then you have your remote desktop virtualization host. And this is where you can run a full remote virtual machine out there. So a lot of times you're going to see this. This will happen more a lot of times in the cloud, where you have that bastion host where you connect in there. You have your tools to manage stuff. A lot of jump servers are in a virtualization environment. VMware has a lot of these out there where you can, remote into a system and run different types of things out there. You can run Windows clients, you can run Linux, you can run Macs even out there virtualized for those things. Now, both modes allow the administrator to create multiple desktop views of these, and each of them can act like, just like your primary workstation. They can have roaming profiles. So if you happen to log in and you get bounced to server A, you go to lunch, you disconnect, you come back after lunch, server A is full up, and you end up getting launched to server C. Well, your stuff would also be replicated out to server C. So you would see the same stuff that you saw on server A is on server C. So you have that fluidity of motion and the ability uh, to have it moved across multiple systems and provide that same end user desktop experience out there. So let's take a look at some of the things. The remote desktop app. This is the Microsoft solution that runs on the terminal services or remote desktop server. As it appears to end users, it actually looks like they're running on their system, and it doesn't matter, what operating system they're using. You know, um, so you have your virtual desktops out there for that. You have the remote desktop web access, and this is where you connect from a web browser. You launch something, and a lot of times you see this when you're running your labs remotely. And these look like it's out there, and these are based on either IIS or if you're not using Microsoft solution, maybe an Apache system for that. Citrix is a company that provides a lot of this for that ability out there too. Also, you have remote desktop and hosted services, and this is like, you know, this is more your cloud solution out there, and an ISP or service provider leases applications to organizations. They run it. Applications run on somebody else's servers, cloud, and the user interacts with the application over the internet. So these are some things you're going to see out there for that. So we also have Microsoft Direct Access. Now this was awesome. When I worked at Microsoft, this was the greatest thing ever. My laptop, uh, when I was there, I would open up my laptop, and it initiated a basically an L2TP secure connection with RDS across the internet. It was an always on VPN from the moment I logged on. It would launch in the background. It would, based on a client-based certificate for that, it would offer an MTLS solution, and we went with that. So it was an alternative to a normal VPN. So it ran seamlessly in the background. There was no client I had to launch. There was no timeouts that ever occurred. Wherever I was in the world, once I opened that up, I was on my corporate network without having to do anything really other than insert my badge into my smart card reader. Now, it was acted at gateway to internal resources, so direct access utilized things like Internet Access Gateway from there, and it utilized a lot of configured resources for that. So it was able to go out there, and it was really a cool product. I really wish these were there more often and more VPNs could emulate that. But it died a slow death because of lack of interest and a number of security vulnerabilities that were associated with it. When the direct access enabled Windows clients connected to the internet, everything was automatically connected. You launched Outlook, it connected to your internal server that was encrypted and connected out there. You could get mail without having to do anything else, just like as you would. So it was really cool. All right, now we're going to talk about the DMZ, extranet, and intranet VPN solutions. Now, there's a term out there called demilitarized zones. In some parts of the world, referring to these are politically not correct. In some cases where you work for an organization that deals in areas, where the terminology DMZ might not be correct, they will use a different terminology. A lot of times it's easier to explain what a perimeter network is or a perimeter zone to an executive than trying to say what a DMZ is, because they usually think of a military border area that's out there. And when you're trying to explain it in terms of computer networking, I've seen a lot of executives, their eyes will kind of glaze over. But if I explain a perimeter network to those executives, they will have a better understanding. Oh, that's the perimeter, that like a fence, that kind of thing right there. It's like, yeah, that perimeter of your building, that seems to get recognized a lot more. But basically, either one is a physical or logical subnet that contains or exposes the organization to external services, to untrusted environments, just like you would have a perimeter to a building. You have your doors and stuff you allow stuff to come in and out of. Same with the DMZ. Inside your building, you may have other doors and locks. Those are your internal controls. But your outer wall and those outer doors are your perimeter. A DMZ, by putting something in there, it adds an additional layer of security to your organization's network. So if you put your VPN inside your DMZ or your perimeter network, Then you can have a firewall that controls access coming into your network, and then you can also have more restrictions on once they're authenticated in the VPN through the VPN going into the rest of your network. You have another firewall that's layering it there that will also restrict access and provide authorized access to certain resources from that VPN solution. So it's not unfettered VPN solutions. Now we have the intranet VPN, and this is where they just place the internet directly behind the internal firewall. Once you're VPN'd in, you basically have access to everything on the internal network out there. So, yep, that's there. We have the extranet VPN solutions, and this kind of links customers, suppliers, partners, and their community of interest to a section of your network that is considered part of a shared infrastructure. Um, these VPNs are connected directly to the internet usually. They have leased lines and stuff, but they're meant for only to create limited access to certain resources out there. And a lot of times you see extranet VPNs, they are more like your Cougar Web type of thing, where it is a SSL portal or something like that to allow that kind of connectivity to internal resources. Now here's what a picture of an extranet VPN technology is. You have the internet there, you have your certificate server, your remote offices, your VPN clients, your telecommuters to connect to the enterprise, and then they connect into the enterprise that way and they can connect out there. So then we also, oh God, this is something crazy. Internet cafe VPNs. The internet cafes were these places where people had a lot of computers and they would go in there and they would just run some time on a computer and get in there. This is the days when computers were expensive. People would go in there. Uh, they were a lot of desktops. Before people had portable computers and portable phones, they had these things called internet cafes. Um, and they would sell internet access. You'd go in there, you'd buy coffee and or a piece of baked good, and you would sit there on there, and you could play games, and stuff like that on these systems. You could check your email. A lot of times you'll see them in these old spy movies from the 80s and 90s or early 2000s. The closest thing I can recommend to one of these now is kind of a Starbucks, but it's still where you bring your own computer in there. Um, so sometimes you will still see these in other countries in uh, Eastern Europe or Asia. You'll still see a lot of these out there. But I have not seen one in the United States outside of Koreatown and Carrollton in a long time. And the one that's in Koreatown is for gaming solutions where they have gaming computers. You can bring your own in there, or you can rent one of their gaming solutions up there. Um, so when you connect to the internet, one of these sites with a wireless connection, and you're using their connection, you do want to utilize a VPN. Uh, the Internet Cafe VPN connection, or any kind of public connection you're going to be making to your organization, you do want to utilize a VPN server for that. All right, let's move on to something more relevant. Um, Online remote VPN options. All right, so these can be, security. These are things you want to make sure your VPN has. Security, of course, that offers that encryption, confidentiality, and integrity. They want to have that wake on LAN support. So, you kind of, when you're like not paying attention and your computer goes in that screensaver mode or something like that, you don't want your VPN disconnecting. So when you touch your mouse, it reinitiates the VPN. It maintains that keep alive for that VPN. Uh, VPNs are also can be utilized for file sharing, for remote printing, and they can also deliver support for Macs and mobile devices out there too. So, Tor applications. These are fun. So, you've heard of the deep, dark web, the dark web. Uh, to access like a lot of things on the dark web, you use the Tor application or Tor browser. Um, it's an application that uses what's called the onion routing. And like Shrek, onions have layers. So this was developed uh, by the United States Navy for a secure network that created anonymity depending on location. It was kind of designed to help increase, uh, communications that were unable to find, that was allowed anonymous access to and from things. Go figure out what that's for. It was designed to kind of help limit the network's vulnerability, eavesdropping, and traffic analysis. Uh, it had multiple proxy servers and relays to provide all these anonymous connections. Uh, the proxy knows only details from the previous proxy server or the next proxy server, wherever it's bouncing it to. And the proxy servers provide anonymity for users by requesting access to resources, making it appear that the proxy server is the one requesting the resources, not the original user. So you have layers there, and there's many layers to trace. That's why a lot of criminal activity and bad things happen on the Tornet for that anonymity purposes. So you can go to a lot of different sites out there. A lot of famous things have happened out there where, the dark web, you see Carter's markets, you see everything like the old Silk Road was popular. If you ever want to go look at what the Silk Road was and who the Dread Pirate Roberts was and how the FBI took them down, that was interesting, where they had marketplaces where they were able to sell drugs, sell weapons, sell services. Even assassination services were offered on these websites. A lot of different crazy things were offered out there. Nowadays, you have different people where you have people putting internet dumps from stolen, hacked material or information out there. It's a place where WikiLeaks dumped all of its information to websites like the New York Times. They have a presence out there on the internet. The Washington Post does too. Facebook has a dark web address even. So there's a lot of crazy things out there on the dark web. So I'd recommend, if you're into security and you're going to be majoring in cybersecurity, this is something you probably want to get to know and understand a little bit. So go have fun on the Tor network, but be careful. All right, so we're planning a VPN implementation. One of them out there that's used for Windows and Linux is OpenVPN. Uh, these can create site-to-site VPN tunnels. It's basically using SSL and TLS or even SSH for creating, a shared key encryption. It also supports non-encrypted tunnels using TCP or UDP through proxies and NAT. So it's kind of like how the Tor works, OpenVPN, but these are more manually configured, where you are configuring between your systems or your other systems that you're affiliating with, and you have direct communication control over them for that. So, like, if a bunch of students want to set up their own private VPN implementation, they could do that. Or if companies want to do that, some small businesses, set something up with their suppliers to, for ordering and stuff. This is a valid solution for that. Now, IPsec is protocol on which most VPNs are based. They have a problem with NAT and the data packets. Last chapter we talked about NAT translation and how that kind of worked there. We touched on it briefly. You could kind of see more of that in an advanced networking topics course there for that. But here we're just touching on the basics. The networks at both ends of the VPN tunnel must have a different IP address range for this routing to work. So you can't have 192.168.1.0/24 on both sides of the network. Everyone has to have their own. Their internal networks have to be on different subnets at least, because you have to change routes and exchange routes with those for routing to work. And these can end up becoming permanent site-to-site VPNs. Uh, they can go through firewalls where both sides have static addresses and they don't change. So if your ISP is, giving you a dynamic address, you may have to request a static IP address for this to remain permanently up. So here's an example of a VPN topology diagram. All right, so here we have the left side, and we have the 172.16.1.0 on the small office home office network. We have our VPN firewall on the left. We have our VPN firewall on the right with the 10.0.0.0/24 subnet. So we have different subnets on both sides. So server 1 and server 2 want to talk. They're going to have to go through this VPN. Now the VPN is going to have a gateway of 176. That's possibly supposed to be 172.16.1.100. All right, because their internal address is 172.16.1.1 the same. So I'm guessing that's a typo there. And its external address is 97.158.253.25. And the external, the other one, so the VPN tunnel is between the two external interfaces. We have the routing between the 10.0.0.102 and 172.16.1.100 over here. Those will be utilized for that. Wish I could edit out these pictures, but this was provided to me from the publisher. All right. So we're going to configure OpenVPN. You're going to see something similar in your lab this week. So typically, this requires a configuration file and a key and certificate files. So a simple VPN with a single server and a static key setup, which is a secret key. These are often called pre-shared keys, rather than using a PKI with public certificates for that. We also have the configuration files that are going to be needed, and these include the comments of what needs to be modified, directives or attributes, that are preceded with the semicolon are ignored, like comments. If you ever do C program, it's in C you do a asterisk slash for a comment. Here you would just put like a semicolon, and that basically does REM statement for a remark to kind of make it a comment so it's not executable. And then if you remove the semicolon from a directive, then that attribute or directive gets executed when the configuration file is read by the application. So in doing that, we ensure that these parameters in the client configuration kind of match those in the server and configuration file, such as the dev, the turn, or tap, uh, thing, or the protocol, whether you're going to use UDP or TCP. And one thing you want to make sure is UDP port 194 is open on the server. So next, this is a sample of what the configuration file looks like. So as you can see right here, you can see all the comments here for not to be read. This is a pound sign, not a semicolon, but these are just comments. And as we move to the next slide, we can see a lot of different things out here. And we see port 1194. We see the semicolon here. We see proto is UDP here. So if we undid the semicolon here, you would also do TCP. And that's kind of what we're looking at in a OpenVPN the file would be server.opvn. So that's there. So next thing you're going to do is you're going to test that the VPN is running. So one of the examples you're going to do is you're going to, like, from your lab, you're going to do a ping 10.8.0.2 from a command prompt, and you're going to try and reach the client, and then you're going to ping 10.8.0.1 from the client to the server. So server's going to try and ping the client's going to ping the server. These are all on your internal network. This is before your VPN is running. Once you do that, you know you have internal connectivity and your internal network is working. If the ping fails, you're going to open up and make sure that port 1194 is open on the firewall. So you're going to do that. I'm sorry, I think I misspoke a second ago. You're going to make sure the VPN is configured and running, and you can do the ping while it is running. I'm sorry. So between the client and server connecting in through the VPN tunnel, that's what I meant to say. If the ping fails, you're going to want to check the firewall settings, and you're going to make sure the firewall has port 1194 open on the firewall. You have a firewall rule there, and you set up a port forward rule on UDP 1194 from the gateway to the machine running the Open VPN server. You also want to make sure the TUN-TAP interface is not firewalled for that. So that would be the external interface that your VPN is connecting to. So when you're also testing, you want to make sure you create a remote VPN in the zones file. So you're going to create your VPN in there. You may want to describe which IPsec interface is to be used based on the names of the zones file. And you can also describe how the network names in the zone file interact with file policy. You can also define the public IP address of the remote sites in the tunnels file. So these are all just files which help give that configuration. So what you want to do is open up a personal tunnel that encrypts the connection and makes your IP address anonymous here. So as you can see here, we have the private tunnel here. And this is kind of easy setup and use. It's good for home office, small office. And so here we have the portal through the GUI here. And you can see, hey, we're connecting from Dallas, Texas, and it is disconnected. So this is what a private tunnel interface looks like. All right, now you have a head start on your lab. A few hints there. Not very good ones, but hey, that's what we cover in the lecture. So next we're going to look at your VPN implementation best practices. Use strong authentication. That means good password management or some kind of multi-factor authentication you can use. You also want to use strong encryption, preferably a encryption cipher that has not been deprecated. Usually AES-T56 is always a good TLS cipher to use. You can go higher than that. Try and stay away from stuff like, triple does. Most of those have been cracked already, so you want to stay away from that. Again, it's best to put the VPN server behind the firewall and have the firewall publish the VPN server. So in summary of this lesson, we've talked about planning and selecting an appropriate VPN solution for your organization. We've talked about remote access alternatives to the VPN. We've talked about VPN solutions, and we've talked about deploying and testing a VPN. If you have any questions, make sure you email me with them or hit me up in the comment sections. All right, thank you, and have a good day, everyone.